how do we add those fractions? What do you got? What's the rule when you're trying to add fractions? What's required? Common denominator, huh? Yeah. So let me write that out. I think you know that. To add, subtract fractions. Number one, get common denom. Now, what is the common denominator? Well, it's the LCD, which we spent a lot of time practicing, how to get LCDs. But let me just remind you, LCD means highest power. Remember we had that opposite thing? The L, the lowest meant the highest, and remember that? So it's the highest power for each letter. So the LCD is the highest power for each letter, and it's a number that all, let's say it's a big number. It might be easier for you to remember it that way. It's a bigger number. Yeah, maybe I should do it that way. It's a bigger number that all the other numbers divide evenly into. Okay. So is this making sense what I'm saying? So those are the first two things. So if we look at these three denominators, we got to say, okay, we got to get a common denominator out of these three. Meaning we got to make them all the same, all common. So there's two parts to the common denominator. There's the numbers in the front, and then there's the letters. So I'm breaking that up into two different ideas, right? So when it comes, let's look at the numbers in the front first off. So we have a 3, and nothing. 1, if you want, right? So that's just going to be 3, isn't it? But what if, let me do a what if for a minute. What if I had like 6 in the middle? What if I had 3, 6, and nothing? What would be the number part of the common denominator? It'd be 6, because 3 and 6 both go into 6, right? You good there? What if I had something like a 4 there? What do 3 and 4 both go into? 12. Getting the idea? So when it comes to the numbers, it's whatever they go into, right? Whatever they go into. So we just had 3. So the number part then is going to be 3. And now, so the LCD on our example, or I'll just write it over here to the side. The LCD for this example is going to be 3. So there's the number part. Now what are we going to do when it comes to the letters? Well, highest power on each letter. Remember, lowest common denominator actually means highest, because container that contains them. That's what an LCD is, right? They have to go into it. So when it comes to X, what power am I going to take on X? What's the highest power you see anywhere? Squared. And what power am I going to take on Y? Also squared, because there's a couple squares, right? Now, what if right here, what if this last one had Y to the 7th? Then I would take Y to the 7th. You got to take the highest one you see anywhere, right? We all good with that? So, okay, so that's going to become the LCD. Now, what do you do with it? So, let me write step 2. Step 2, you multiply top and bottom. So top and bottom to how about by whatever's missing, to make denoms the same, common, right? So we're going to multiply the top and the bottom by whatever's missing to make the denominators the same. Whoops. So let's do that. So I'm going to come in here and I'm going to say, okay, multiply top and bottom of this guy, top and bottom of this guy, top and bottom of that guy. Right? And we're trying to make all the denominators the same. That's the goal. Our focus is on the denominators, right? Common ground, common denominator. So, what is this first guy missing to make it the same as the common denominator? Nothing. So we don't do anything with that guy. How about the middle guy? What's he missing to be the same as the common? What does he need? He needs another X. You tracking with me? We're just giving each of them what they're missing. How about the third one over here? What's this guy missing? 3 and Y, top and bottom. We good? So you multiply top and bottom by whatever they're missing. And do you see how all three denominators are the same now? 3x squared y. If you multiply that out, it's going to be 3x squared y. Multiply that one out, it's going to be 3x squared y, huh? We've made them all the same. And we haven't changed any fractions because we do the same thing to the top and the bottom, haven't we? So no fractions are really changing. It's just we're getting common denominator. So those are the two steps. I'm going to go to a fresh screen and work out the rest of the details. So what do we have? We have minus 5. That first one hasn't changed at all. Plus the second one, 2x on the top, over 3x. Again, just multiply out. They're all going to be the same. 3x squared y squared. The third one is going to be what? 7 times 3y up there. 21y over 3x squared y squared. We good? And now, combine them. Now that the bottoms are all the same, you don't need 3 of them anymore. Just make it one common denominator. And there we go. Hey, can I cancel anything? Can I simplify this? Can I cancel out x with x, y with y there? We talked about the whole Costco rule, right? Plus that top is plus and minus. So the bottom is fine. The bottom would be totally ready to cancel. But the top is plus and minus, which means you can go like that on the top or nothing, right? All the package or nothing, like shopping at Costco. It's all or nothing. Pluses and minuses glue things together. Now I wrecked it. Let me put it back. Whoops. How it was. So we're just done right there. Nothing more can be simplified. Good? Know all those fraction rules? A question was asked last time. By, I think it was Carolina, right? Carolina asked a question just about, well, can we just do these on our calculator? Why are, the ordering ones and all that kind of stuff? I said I'd give some thought to it. So I will have a small part of the next exam that's going to be no calculator, and then the rest will be calculator. So there will be a little small section where you have to, and I'm really honestly not trying to torture you. I know it feels like torture, something like the little no calculator part. But you guys know you have to take Math 100 after eventually. There's this class 10A, 10B, and then Math 100 to finish your math stuff for your liberal studies. I was just talking with the Raji, the head of the math department, just moments ago. Anyway, he was telling me how much harder Math 100 is, and really encouraging me that I'm not doing anybody any favors if I make things too easy, because they're having a group of students that came from another college that are having trouble passing the 100 because they had too easy of a 10A, 10B. So anyway, I really am trying to do you good. He encouraged me, no, hold a faithful standard. Make sure, and especially you want to be even more important than that, not just passing Math 100. That's not your whole life, is it? You want to be a teacher. You want to teach. In the Common Core curriculum now, they really require understanding from the kiddos. And of course, you as the teacher, of these kind of things. So I really am going to try to help you to really, really get the fraction thing. I'm glad to help. See me office hours. I'll go as slow as I can with our 3 hours every week. But yeah, there'll be a small part. So can you do this by hand? There'll be a small part of the test. I'm not going to be putting big numbers on you, I promise. On that little first part of the exam too, that's no calculator. There's not going to be anything like, 17 times 3,005. No, nothing. No big crazy multiplying, dividing numbers. Just simple numbers, just to make sure you can do all the fractions. Really have a concept of the fraction stuff. So, how do we do it? So, how do we subtract those two? I think that's a great idea. Yeah, there's lots of ways you can go. I think that's a really good idea. Let's change that guy, that mixed number, into an improper fraction. Remember how to change a mixed number into an improper fraction? Yeah, you multiply and you add, huh? So it's 2 times the 8, add the 5. 2 times 8 is 16. Add the 5 would be 21. Like that. 21 eighths. We good so far? And then, let me let you do the next step. Rather than me just whip it out. Sometimes I probably go too fast. So when you make when you do the common denominator, you could actually do 48 or 24. I don't know if you noticed. Either one would work fine. The lowest common denominator is 24. That'd be the simplest numbers. But if you did 48, that's totally fine. I'm not sure which way you did it. Let me just assume you didn't notice 24. If you just multiplied top and bottom by 8 and 6 like that, that would work. Or you could make them 24. That would work too. And then you would get what? 8 48 minus, what's that, 126 48. You could do that by hand, right? 6 times 21, 126, like that. So, all right, so we've got that, and now we can subtract them. 8 minus 126, you can just subtract. 2, put a 1, put a 1. I'll just show the by hand. 118 is the difference. It's going to be negative, though, huh? So it's going to be negative 118 over 48. That's got to be reduced, though, doesn't it? I'm just like running out of room here. Let me scoot this over. So bring it up here. So negative 118 over 48. And then reduce that fraction. Just divide by 2, top and bottom. Divide by 2. That would be negative 59/24. I don't know if they want a mixed number or an improper fraction, honestly. Let's take that and change that back to a mixed number now. How do you change an improper fraction back to mixed? Divide, yeah. Yeah, if changing from mixed to improper was multiply, then reverse has got to be divide, huh? So I'm going to go to a fresh screen here. So we have, we're still on 15e, and we have minus 59/24. Change to mixed, which means you long divide denominator into the top, right? Bottom into the top. So let's do that. So that would be 24 on the bottom here, 24 into 59. How many times that go in? 2, I guess, right? 8, 48, remainder 11. So what is it? 2, and then what do you do from there? It's the bottom over the left, huh? 2 and 11, and it's negative, because it was negative back here. And there it is. Is that okay with those steps? How are we doing? You remember all that stuff? Sort of, kind of? So do you guys know you can practice the homework more than once? Do you know after you answer the questions, you can go back in and it has an option to just practice and review, not change your grade, like after you already got 100% or whatever, and you don't want to mess up your grade. So you can go back in, it'll give you other fractions. It'll change the numbers so you can practice. Is that what you were wanting? Mr. Stern, I want more homework. Please tell me how I can do more homework. I could tell you wanted that. So there it is.
So
Harmeet, right?
Yes.
Yes.
So the negative goes before the 2.
Yeah, good question. Absolutely. Yeah, that just means the whole thing is negative. The 2 and the 11/24. Yeah. Right. We good? All is well? All right. Let's go back then to F. Minus 4.5 plus 1 1/4. So F 15F minus 4.5 plus 1, was it a 4th? Yeah, plus 1 1/4. All right, try that one. Mixed numbers. You can leave them mixed if you want. I'd probably change it improper, but both ways are acceptable. Yeah, I'd probably change it improper. I think it'd be easier, probably, for you. So change those to improper, multiply by the denominator and add the top. So 4 times 2 is 8, 1 is 9, 1 times 4, you multiply the bottom and you add the top, right? 4 add 1, 5/4. We get to there, and now get common denominator, and combine them together. What's common denominator going to be? Going to make them both 4? Yeah, so got to multiply by 2, top and bottom, right? So why do we multiply top and bottom by 2? What if a kid asked you that? Why can't we just multiply the bottom? Yeah, because you changed the fraction, huh? Right, the whole deal is we're not changing the fraction. If you multiply top and bottom by the same thing, 18/4, if you reduced it, would go right back to 9/2. They're the same thing. Now we can add them up. So that's minus 13/4. Good there. Minus 18 plus 15. And now can you change it back into mixed number? So change it back. That's right. Change to mixed. So long divide bottom into the top, right? 4 goes in there. What's that? 3 times 1. So the answer is 3 and 1/4. Bottom over left. And it's negative. Negative 3 1/4. How are we doing? Questions on that one? All right, I'm going to move on to change that to mixed. Long divide. Long divide. The denom into the numerator. So 7 into 129. Can you carry that out by hand? So that is something that you can do by hand. Remember a little while since you've long divided by hand? So what do we do? Where do we go first? We just go the 12, right? You with me on that? You just find the first thing you can go into. So 7 goes into 12. How many times? Just once. And you put the 1 over the 2, right? The last digit of what you're going into. 1 times 7 is 7. Subtract 5 and then bring down the 9. 7 goes into 59. Remember that? Now, what do you do what if you're in the middle of the test, part 1, no calculator, and you're like, I don't remember, I'm a little rusty, or you sort of half remember the time tables you're not sure? You want to be sure, huh? Math is about being sure. So I would just go over there and add, if you're not sure, then just add up some 7s real quick. 14, add another 7, 21, add another 7, 28, add another 7, 36, no it's not, 35, 35, add another 7, 42, add another 7, 49. This is a little tedious, huh? 56, oh, there it is. So 7 times 8, you can count them, 8 is 56. So just make sure. So, okay, what's the answer then? It's 18 and 3/7, isn't it? It's always bottom over left. It's always bottom over left. We good? There? Feel free to stop me. I'm going to try to move fast to get to the hard ones for you, but feel free to stop me. Some good things. I don't know. I'm not teaching with it myself, so I'm not a good judge probably, but I certainly think there's some good things they're doing with it, for sure. And one of those things is really trying to give kids a real feel for the math. So let's take a look at this. Could you do this? Do you have a feel? So as you look at this, they're going to say, look, each of these fractions, let's start with this one. Is that closer to 0, or a fourth, or a half, or 3/4, or 1? So 1939. So if I say, hey, 19 out of 39 people in the class got an A or a B. That's pretty close to B. I think we had 20 out of 36. Anyway, say 19 out of 39 got A's or B's on the last test. What portion of the class is that? Is that closer to a fourth, a half, 3/4? That's real close to a half, isn't it? It's real close to a half. How about the next one? 2 people got A's and B's out of 173. That's rough. 2 people out of 173. What's that closest to? Yeah, that's close to 0. That's closer to 0 than it is to 1/4. Do you feel that? Do you see that? Because 1/4, what would 1/4 be? This is 170. Half would be 80-something. And then half of that again would be 40-something. Did you just track with that little mental calculation I did? I just estimate. I said, well, could it be the 4th? Because it's either going to be the 0 or the 4th here. Which one of those is it? It's not a 4th, because if you had 173 people, what's 1/4 of that crowd? Well, I don't know. It's about 80 would be about half. That'd still be under half even. And then half of that would be 40. So 40 out of 173, or even a little more, would be close to 1/4, wouldn't it? It's not even in the neighborhood of 40 people. It's only 2 people. That's close to 0. How about the next one? 147 over 197. What's that close to? 0, a fourth, a half, 3/4, 1. Yeah, do you see that's pretty close to 3/4? That's more than a half, right? Because a half, 197 is about 200. Just think ballpark. 197 is about 200, isn't it? And 147 is like 150. So if 150 people out of 200 people, that's 3/4. That's really close to 3/4. The last one, 11/12, what's that close to? Yeah, that's almost 1. That's almost 12/12, huh? That's almost the whole thing. Okay, good. On these. So how about if you add, now they don't want us to actually add those up. That would be really painful. So without actually doing it, just a feeling again. They just want to see if we have a sense. They want to help us rise in our fraction sense, which is valuable. So let's do that. 11 over 23, 14 over... Now, let me help you get a strong sense of that. So as you look at this, I would think of these as simple. I would try to think of these as really simple fractions that are close to that. So 9/19, that's close to what fraction? What simple fraction? Like the ones we were just looking at, 0, a fourth, a half, 3/4. That's really close to half. Do you see that? 9 out of 19, that's like 9 out of 18, pretty close to half. How about 10 out of 21? What's that close to? Another half. That's like 10 out of 20, pretty close, huh? 11 over 23, what's that close to? Another half. 11 out of 22 would be half. It's close. And how about 14 to another half? So if you said a half and a half makes a whole, and a half makes a whole, so what do we got there? It's really close to 2. Those fractions are going to add up really close to 2, aren't they? Does that seem reasonable? See how we went about that? You can do that without a calculator, right? How about the next one? How about part B there? Part B, 32 out of 41, or let me bring it down here. So 32 out of 41, and then 4 out of, 1,000? And then 2 out of 2,000. Okay, 32 out of 41. What's that pretty close to? Yeah, 3/4. Y'all see that? That's like 30 out of 40, huh? 3/4 of the crowd. Okay, 4 out of 1,000. They said, 4 out of 1,000 people got an A on the test. That's almost nobody. That's pretty close to 0, huh? And same thing here. That's pretty close to 0. This is going to add up to be basically 3/4. Y'all see that? 3/4 plus nothing plus nothing. These guys are effectively close to nothing, aren't they? Good? That making sense? All right. 20. A parent died, left an estate to 4 children. One had a third, one had a sixth, one had a sixth. How much of it? Let me write it out a little bigger for you. So the first was a third. Wait, a third, a sixth, a sixth. So a third, the second, a third, the third, a sixth, and what does the fourth? So basically, there's an inheritance. There's an estate. The first child got a third, the second got a third, the third got a sixth. What portion of the estate was left for the fourth child? So how can we figure that out? What are we going to do? What's that? Add them up. 1/3 and 1/3. And add those 3? I think that's a good idea. There's a lot of ways you could do that. That's a great way to go. So, all right, can we add those up first? So go ahead, add those up real quick. And that won't be the final answer yet, but that's a good, really good first step. I think y'all know that's not the final answer, but we'll get there. So to add those up, what do you got to do? So we're not estimating here. Here we're getting exact. We're back to getting exact answers, right? Those estimating ones for a couple problems. We're back to regular exact answers. So what do we do to add those fractions? Common denominator, top and bottom by 2 here, top and bottom by 2, so we don't change the fractions, huh? And so then 2/6, 2/6, 1 6 adds up to 5 6. So those 3 children inherited altogether 5 6 of the estate. So how much is left for the 4th child? You got it. Yeah, it's easy. Once you do that, it's simple, huh? So the 4th child, gets 1 6. That's our answer. Very good. Good on that? That one's not too bad. 3 pieces of one type of ribbon, different customers. 3 5/8, 9 4/5, 16 1/4. What was the total length? Okay, so let's move that over. So 21. We've got 3 5/8 and 9 4/5. So we're just adding them up, aren't we? These aren't the. I was thinking of other problems. These aren't as deep as I was thinking. There's other. I was looking ahead. I guess it was the next assignment that has. There's some deeper word problem type fraction questions coming. I guess it's in the next section. So yeah. So this is just adding them up, right? Just add up those 3 fractions, get the total length. I mean, it's not. I would probably leave those as mixed. You don't have to. You can do whichever way you want. But just because they're big, and I don't want the numbers to get too big, I would probably just leave them as mixed and make the denominators common. Can you do that? Let me give you a second there. Make the denominators common. Yeah, so you're probably looking at that 8, that 5, and that 4, and wondering what's a common denominator. You've learned different techniques for finding LCDs, right? So what's the LCD for 8, 5, and 4? Remember how about the prime factorization method? Remember that method? Yeah, this would be 2 to the 3rd. This is 5. This is 2 to the 2nd. So remember how to do the LCD from the prime factorization method? What do? For the lowest common denominator, you take the highest of each of those. So when it comes to 2's, 2 to the 3rd. Comes to 5's, you just got 1. 2 to the 3rd times 5, that's 8 times 5, 40. We good there? 40. And you might have just been able to spot it. That's fine. If you can just see it, 8 times 5 is 40. Is everybody good with how I found that LCD? Remember the method we learned in the last section of the course? You just break them down in primes, so you take the highest power for each prime. Same thing you do when there's letters, huh? Because that's the container that would hold any of them, right? That'll hold them. All right. So now let's go make those denominators, those fractions all have mixed numbers all have a common denominator of 40. Let's go back here. I'm going to multiply top and bottom by 5, top and bottom by 8. Right, see what I'm thinking? I'm just making 40 in the bottom, right? So 5 times 8 is 40, 5 times 8 is 40 again. And then what am I going to do for the top and bottom of the 1/4? 10 to make that 40, huh? So what do we get then? Bring it over here. We get 3 and 25 40ths plus 9 and 32 40ths plus 16 and 10 40ths. So I'm just going to add up the whole numbers separately. What's that? 12, 15, 18. So 28. And then add up the fractions separately. 25, 32, 10. 7, 3, 4, 5, 67. So what do we got? 28 and 67 40ths. Let me slow down. Am I losing you? We're not done. So see what I did? I just grabbed the 3 whole numbers, right? The 3, the 9, the 16. And added them up. And then I added the 3 numerators up right here. Good? And the denominator is still 40. That hasn't changed. Common denominator. Now, can we leave our answer that way? Actually, no. That would be the one form that's not allowed. Because you see how it's a mix of mixed numbers and improper fractions? We can't have that. We got to be all mixed number or all improper fraction. See what I'm talking about? Right? You see, when you do a mixed number, the fraction part needs to be proper. What do I mean by proper? the top needs to be smaller than the bottom, huh? Right? That makes sense? So, let me go to a fresh screen if you're okay with that screen. 28 and 6740. So how do we change it? We can't leave it that way. How do we change it to a normal mixed number? What are we going to do? May have an idea? We could multiply, but I think it would be easier probably just to grab this guy and just change him and then put it back with the 28 when we're done. I think it would be easier. How do we change? Just pretend the 28 is not even there for a minute. What if somebody just gave us 67/40ths? How would we change that? Yeah, for me. Yeah, change to a mixed number.
And if you give a whole number, you add it to 3 plus 9 plus 16.
Add it to what?
Add it to the other whole.
The other whole number, the 28. Yeah, or whatever they were before. Yeah, I see what you're saying. Yeah. Does that make sense? That's exactly what I'm thinking too. So just change this thing. So bottom into the top. Remember how we change any improper fraction. Improper means top bigger. Right? That's improper. It's not proper. You should not do fractions that way. Right? Okay, so it goes in there one time. 27. So what does that mean? That means this part is 1 and 27/40ths, huh? And we have the 28 in front also. We good? So then that's 29 and 27/40ths. All is well? Questions?